everyone. Today we are going to study about neural bias classification. Now, for building a neural network in Python. Now let's have a practical example. Okay. For understanding neural networks. Neural networks are a class of machine learning model inspired by the human brains. They consist of interconnected nodes called neurals, which are organized in layers. Now, these networks are capable of doing complex patterns and making predictions. Now, for the data preparation, load the MNIST dataset for flatten the images into 1D arrays, normalize the pixel values, and converts the class labels to one hot coding models architecture. Now, secondly, then we have to create the sequential model for the with two dense layers. First layer is for 128 neural and LU activation, and second layer has 10 neurons with soft max activation for probability distribution. Now, optimizer, Adam optimizer is used to update the model's weight. Loss function is used for categorical class entropy to measures the model's errors. Matrix, that is, the model performance. Then model training, we have done model training on the training data sets with 10 inputs and data size of 32. Validation of the data with the data model performance. Model evaluation, we have already known. Experiment and hyperparameters, try different number of layers, neurons, activation function, optimization, regularization. There is a use techniques like dropout or L1 L2 regularization from preventing from outfitting. Data augmentation is used to increase the size of the data set by creating that data samples through transformations like rotation, flips, zooming. Transfer learning is a leverage pre-trained models on large data sets to improve the performance of the smaller data sets. Now, by understanding the model experiments and different techniques. Now, let's go through the coding part. Now, import TensorFlow. Now, we are importing the TensorFlow STF. TensorFlow keras.model. Now we are importing sequential, dense, MNIST and categories. Now we are next we are have to load the MNIST data set. First, that is xtrain, ytrain and xtest, ytest. Splitting the data. MNIST, load the data. Okay. Now we are going to identify the shape, that is by flattening the images into 1D array. Xtrain, reshape, and xtest, reshape. Now normalize the pixel by xtrain equals to xtrain upon 255 and xtest is equals to xtest upon 25. Now convert the class labels in one hot encoding. Two categorical and for xtrain and xtest. Two categorical, we are using that function. Now to create a simple sequential model sequential dense 128 activation ReLU input shape and dense activation softmax. Now we are going to compile the data with the help of compile function, optimizer, Adam, loss we have, categorical cross entropy and matrix are the accuracy. Models, now we have to fit the model in this, train the model and then evaluate with the help of evaluate function. Now we can test with the help of test accuracy. Okay, so that's it for this video. Now in the next video we are going to learn about k-mean clustering. Thank you so much. Don't forget to share, subscribe and like to my video. See you in the next video.